So hello everyone, in this video I am covering the array. So arrays are like if you have a particular geometry and you want to copy it even in rectangular directions or polar direction, so we call it array. So let's see this through an example. Let me disconnect this first. So let's look at, so I am using transform, then you can see the array. I'll be using few options from here. So let's see the input parameters which I will use here. The first one is actually a geometry, which is cylinder. You can see a cylinder here. Let me turn on the preview here first. Yes. So you can see a cylinder here, and the next one is a three sliders. So in the sliders, the minimum value is 0 and the maximum value is 100, and it only takes the natural numbers. Next one is the angle. The limit is between 0 to 2 pi. It contains real numbers. And the next one is a vector, which is between 5000 and 50010. I made this vector using vector, and you can see here vector 2 point. So the next one is actually a plane, which you can see when I click on preview. Yes, this is a plane. I can change the it. Actually, how this plane is made, I have covered this in last video. You can go and see that one. And there is a curve which I'll be using, and there's a rectangle. I will tell more about rectangle in further video. So let's start. So our first thing is the first component is the array box. So let's see the input parameters of the array box. The first one is a geometry, second is a cell, and these are x, y, z, like how many components do we want in x, y, and z direction. So let's first connect the geometry. So when I connect the geometry, let me turn on the preview here. You can see it now that there are actually the copies of our cylinder. So let's see how it is working. Let me zoom it, please. So C is a locally defined box which we will make our own later. You can see in X cell direction there are 4 elements. So 1, 2, 3, 4 in X. In Y there are 3, 1, 2, 3. You can see there are 3 in Y, and in Z there are 2 elements. So let's make a box for ourselves. So box 2 point I'm using. So for the what it one does, it takes two corner values, first corner and second corner. For the corners I am taking these particular panels. So my first corner is 5000 and the second corner is 50010. So we have a corner, we have actually a box. So when I connect this box with this, you can see we have it. No, we have to change the values actually. So it's a 5000 in along x-axis. So let me change the values here. So let's make it 0, 50 and 50. So you can see we have a box here. Let me remove it first. So this is our box. So let's connect it with this element. Now you can see we have now I'm going to use these sliders. Let me connect it with fewer values like 6. Actually I'm going to reduce the values here because it's going to cause mess. Like 10 is fine. 10 is really fine. And 10 here. We can make it like 20. It's okay. Yes. So you can see we have something here. So let's connect our slider here. X count, Y count, and Z count. So what I'm gonna do, I'm gonna reduce the values here. Like 2, and this one make it 3, make it 4. So let's see what is happening here. So you can see, like first of all, what I did, you can see the X count is 2. What it means, like there will be only 2 elements in X direction. So you can see this is the X axis where there is, you can see there So this is a x-axis. There are only two elements, and the distance between the elements will be decided by the box. The box. So you can see the distance of the box along x is 10. So the distance between the components along x is 10. So along y is 20. So along y the distance is 20, and the y count is actually 3. Let me see. Yes, you can see y3. Yes, actually this is the 20 and this is the 3. 1, 2, 3. Now let's look at this one. This is 4 z count, and the difference of distances is decided by the box distance, which is here 10. So let me zoom it out and let's see magic. So when I click on x, you can see there are more elements along x. I can change along y here using these sliders, and even along z. So you can see we have like multiple components. So let's turn off the preview and bring back our sliders here. And we don't need box anymore. So let me delete it. I'm gonna disconnect everything here from here for better view actually. So first one was the array box. Let's see the second one. Second one is the array curve array. So we're gonna using this curve. What it does, it forms the array of the particular component along the curve. So let's connect the geometry, and our curve is here. Let me put it here. So curve is connected. Now you can see we have elements along this particular curve, and we can decide how many. So actually more number of elements you use, better the better the your components get along with curve. So let's increase the number of elements. So you can see we've got an array here. Let me go to the view here, restore, and you can see it from the top view. It is trying to follow the curve here. So we are done with this one. We can animate using this. It would be pretty much cool if we are animating using the array. Next one is array linear. What it does, it takes a geometry. So it took a geometry, that is our cylinder. And the next one is the direction. In which direction do we want? So for the direction, I would like to give this one, which is actually along z-axis. And the next parameter is actually like how much do we want, how many elements do we want. And we are done with this guy. So you can increase it, decrease it, whatever you want. So I'm going to delete this one. Next one is array polar. It deals in 3D. So let's connect the parameter. The first one is a geometry. Next one is polar array plane. Let's connect the top plane, which we made in the last video. One thing I'd like to know you. Yes. Focus on the top view here. So you can see the top view. So if you want to change the radius of this, circle, so what you can do, you can change this particular parameter of this plane. Now you can see it's increasing. So the radius is equals to this particular y component of this plane, which you can see as I vary, and it gets changed. So the next element is count, like how many circles do you want? Actually, how many the elements do you want? So I can change it whatever value I want. Next one is the angle. I'm gonna choose the angle from here. You can control the angle from here. So this is how it works. Array polar. Let's go to the next one. Next one is rectangular array. This one is nice. So it, like in the box we were making elements in 3D. What it does, it does the same job in 2D. So let's connect the geometry and see the rectangular array cell, which I'll make our own data. But so I want 4 elements along X. Let me reduce the value here, like 10 elements along Y. You can see. So the next, the parameter, this one takes the rectangular array cell. So I'm connecting a rectangle here. Now let's see how the distances are controlled here. So let X size, yes. So you can see I can control the size of X using this particular. So you can see here, this is a greenish rectangle, you can see. So the distance between the X components can be controlled by the distance of rectangle along the X, which is 11 right now. So if I want to change this, I have to change the dimensions of the rectangle. Same can be done with this particular Y. Let me connect the same elements, and you can see it. I'm controlling the direction. So this is how it's done. So we are done with actually the transform and array.